Right, so we're really going to work on worksheet 8 today, but we're going to first go back and finish 6B, but we're going to start by answering some questions on 7. And the question that was first asked of me is this number 17. It says find the values of B and C. Did anybody try anything? This kind of got confused. All right. I'm going to show you the way I did it. I'm not sure you want to write this down. I kind of like Brooke's way better. What I did was I said I have a vertex, so I started with vertex form. What do I know? What can I put in here? Okay, we do have an A of 2. I'm sorry, an H of 2. We have a K of -7. And we know A is -8, right? We're done, except they want it in this form so that we can figure out what B and C had to be. So what I did was a whole bunch of algebra, because, you know, I'm a nerd. I went x minus 2, and I FOILed all that together. Everybody knows where I got that middle term, right? -2 and -2. And then I distributed, because that's the way I roll. More fun, right? And I got down to, so what are B and C? B equals 32. And C equals -39. Everybody okay with where I got those down there at the bottom? From right down here? Okay. Brooke, she's smarter than me. She had a brilliant idea. She went, remember this? What does that find? The x of the vertex, yes? So do we already know the x of the vertex? It's 2. Okay. Well, we don't know B yet, but do we know A? So she got 2 equals the opposite of B over -16. These could cancel each other out, the negatives. Multiplying, we get B is what? 32? Nobody's going to do 8, right? It's not 8 over 16. Got to multiply the 16 over here and get 32. We good? Okay. Then once we know that, how can we find C? She went back to the original equation, y equals ax squared plus bx plus c, and she put in this point, -7. A was -8 up at the top of the page right here, right? I forgot to write that down. X, what can we put in for an x? 2. B we just figured out is 32. X is still 2. And now can you solve that mess for C? So I don't really know which one was more time consuming. I'm less likely to make a mistake probably with her method because there's a lot of room to mess up over here. This is just calculator typing. I think it comes out -39. It should, yes, but I think it does. Okay? So now you guys can try 18 using one method or the other. Okay? Yeah, that was a really good idea. And I would like to be able to tell you that that's not on the test, but I'm not positive because I think there used to be one of those kind of questions on the summative at the end of this unit. So you might want to put yourself a little star by those. Go back and review how I did those later for the test. The test is, I think, Thursday or Friday next week. Okay? I think Friday. Did anybody else have a question on this? best one, I just did number 17 two different ways, if that's confusing you, because it's the same problem. I just did two. Yes, Emerald? I agree. I had a hot mess going. Somebody asked me about 19. Was it you, Kate? No? Somebody asked me about this question, and I was like, I started it, got all this going. That's because I only think of intercept form, of vertex form. So I was thinking we had to have an answer in vertex form. But there's a form called x-intercept form, right? It says y equals the stretch times the two intercepts multiplied together. So what does this make one of these factors? X plus 3. And then this makes one of the factors x minus 1. Now what? We have to find a, but we can put this point in, right? So 2 equals a times 0 plus 3 times 0 minus 1 is 2 equals a times 3 times negative 1. We divide by negative 3, get negative 2/3. Did anybody else get that, or did I mess up? Did it say we had to have a particular form of an answer? So there's a perfectly good equation of a quadratic. Yep. I finally figured out after I went back and looked at my answer key, and I was like, oh, an equation. This is not a hard problem. Was it Morgan? Was it you yesterday? That's who it was. I'm sure there are other ways you could do that problem. Remember we talked about how you could average the x's, find the vertex, but anything else anybody's run into? What about the getting ready for quiz worksheet? I don't know, what did it say? Preparing for quiz yesterday, the one I passed out that had the answers at the bottom, upside down, one-sided. Did anybody have a question on that? It's not required, it's not part of the homework check, but guess what? If you need a retake on tomorrow's quiz, what's the first thing I'm going to tell you to do? Show me that you did that worksheet, right? Or go back and do that worksheet as extra practice.
Okay, so we're on homework check number 4. Right?
Yes, homework check 4 is, yes, homework check 4 is what's due tomorrow. It's the bookwork and worksheet 5 and worksheet 7. All right. If no one else has a question, can we go back to worksheet 6, side B? Because we didn't quite finish. Do you need me to do one of D or E, or did we just kind of go through that enough times that you remember? We okay? D and E are the ones we just did a couple of where you're starting. Yes, or you want me to do one? Do one quick? Okay. Just as a warm-up, if I was doing this question, the directions are up above, but I would start out with x minus 2 squared plus 5 because of the vertex. Does that seem okay? And then what? I use this as h and k, which were a very special x and y, and then we have this x and y back here. And we have 6 equals, I'm going to move this a to behind this number. 4 minus 2 is 2. 2 squared is 4. So I have 4a plus 5. Now you can finish and find a. And then you just slide it back in here and you're done. Is it 1/4, guys? This is 6b. Same thing with the D. There's a bunch of those on the homework. Everybody okay? All right. that brings us to this question, and I don't remember how far we got yesterday. What parts did we get through that felt really comfortable, like, yes, I get that? Do you remember? Because I don't think we finished all of them. Nobody wants to fess up where I left off? Because I was kind of remember I was recording as you ran out the door. Yes, I was. We kind of got through C. You were pretty comfortable that you knew what I was doing through C. All right, so this is what I'm going to do. I'm going to. Okay, okay. I would like you to all go back and type it in to your graphing calculator, please. And this is really super sad that I have this in long-term memory, but I've done this question so many times, I can type it in. Whoa, what's happening? So negative 16x squared plus 132x plus 60, right? Yep, that's pathetic. Okay, then we decided... I'm going to redo this because students struggle with windows all year long. So I had a standard window and there was something going on, but it's not an appropriate window. You will be graded eventually, especially I know on the final exam there's a question, what's an appropriate window for this question? Time can't be negative, so the x can't be negative because in this question, x is time in seconds and y is what? Height in feet, okay? And when we changed this, we still had issues because it went off the top. Matter of fact, we saw basically nothing. We also can't go underground. Our rocket is not going to go underground. We found out we could do like 0 to 400, and that showed us the top. Now, I'll talk about one more thing real quick. If I do trace right now, do you see how it like blots out part of my picture at the bottom? Sometimes I like to shift my graph up a little bit. So if you told me you wanted your window to go like negative 50 to 400, just so you could, when you hit trace down at the bottom now, your numbers are down there below the line. It doesn't cover anything up. I don't care, that's fine. But can I talk about one more thing? What is this X SCL and the Y SCL? It's called the scale. Does anybody know what it does? It changes these little dots. See how at the bottom they're counting by ones, and it goes 1 to 10 and there's 10 little dots. But you see up and down right now it's this solid black line because it's trying to put 450 but little dots in there. If you were doing a science project and you had to go from negative 50 to 400 on a graph for your science lab report, what would you count by? Not ones, 50s, 10s, 25s, okay? We could do 50s, it doesn't matter. You don't have to change your scale. I'm never going to grade you on your scale. But if you set your scale to 50, you can now, it'll look nicer and you can estimate what this peak is. You can go, well, 50, 100, 150, 200, 250, 300. Looks pretty close to 300. Do you see what I'm saying? It just helps make it nicer to, that's all. Okay. We did part A, B, and C I did it by doing trace. I went trace 0. At times 0, it's at 60. At 3, it's at 312. And at 8, it was at 92. That's how we got those answers. You can scroll through the table as well. My issue with the table is sometimes I open my table and X is at negative 16. So to go from negative 16 to positive 8, I got to scroll 24 times and my finger gets tired. Okay? What? When you hit trace and then type the number 8 and enter.
Okay, I hit trace already.
Okay, wait a minute. We had this problem and I don't remember what the issue was.
So I just scrolled on my calculator.
You have a plot on? And so it's scrolling in the plot, that's the problem. Go to y equals, go up onto that and hit enter. Twice. Now it's off. Okay, see it's not lit anymore. Now you should be able to go trace.
If you go to the table set, you can make your table.
Yes, absolutely. You can make your table start at 0, yes. But to still, depending how many values I'm looking at, I just personally think it's faster to just do trace. All right. What time did the rocket hit the ground? If I went to the nearest tenth of a second, the table could help, but you'd have to change how the table's set up and all this kind of stuff. What I want you to use is, anybody remember? We're going to find where it hits. This is called an x-intercept, yes? But another word for an x-intercept, which there are about 4 or 5 of, is a 0. Eventually in this next unit we're going to talk about a 0, a root, a solution, an x-intercept. Those things are all the same. So we're going to have 0. And remember, I don't know if we talked about this, but 0, it's left bound, right bound. It wants to know, where do you want me to look for 0? Between what two numbers? I type, you can just scroll around. This looks like it's somewhere between 5 and 10 to me. So I'm going to type 5 as my left bound and 10 as my right bound and hit enter. And it found it at 8.68. Did anybody else get that, or do I have something wrong? Okay. So, yes. No? We're good? This is 8.68 seconds. And what is the maximum height? Oh, that's not here. What do we need to do to find the maximum height? Find the max? Yep, but we just did D, right? We good first? Okay. Then we're going to do the maximum. So we're going to do second trace and pick maximum. It does want a left and right bound again. Okay. It's up here somewhere, right? So what do you think those x values are between? It's in this window. There's only one in this. You could do 0 to 10. Watch up here, guys. Watch my hands. We're going to have graphs that do this. And that way it can have 2 maxes in the same window. Do you know what I'm talking about? Like you had mountains here. Then you have to narrow your down where you find it. Otherwise it's confused because there's 2. It will find a max in any window. Let me show you this real quick. If I say between 1 and 2, it's going to find a maximum. Between 1 and 2, there's the maximum, right? Because it's as high as it goes between 1 and 2. But in this window between 0 and 10, there is only one what's called relative maximum. And you guys already found it, I'm sure. All right, so what are the answers to questions E and F? The time at the maximum is which number? 4.12. And the height at the maximum? 25 feet. I don't care how many places you went out today. It doesn't. Bessemer, are you doing okay or you need help? You got it? Okay. What time is it exactly 300 feet above the ground? This is a feature we're going to use a lot. This is a really bad question because the only way to get exactly would give you like a radical answer because you'd have to, oh, let me talk about what you'd have to do. You'd have to write 300 equals negative 16t squared plus 132t plus 60. You'd have to subtract the 300 and then you'd have to probably use quadratic formula. Okay. What we're going to do, because we're okay with not exactly being exactly, we're going to put in a line at 300. Now, earlier today, third period, I've done this entire example, and somebody says, where did you get that line? So please type this in, otherwise you don't get that line. Okay? Everybody put it in 300? Now I have two things graphed. I wish I had my color emulator up here because one would be red and one would be blue. Okay? I don't have it because it seems to work much slower than this one and it was annoying me, so I tried this one. Now, we want to know it hit 32 right here on its path up, and then it hit it again on its path down, yes? So we want to find those points of intersection, which leads into today's lesson. So I'm going to choose choice 5. It doesn't say left bound, right bound, guys. What does it say? Intersection. Second trace. Second trace. Choose intersection. Everybody find it? Claire, I don't know if they need your help. I don't know, because we didn't do intersection before. You want to check on them for me? Thank you. All right, so we did intersection. Then it says first curve, and if you hit enter, it goes to second curve. If you only have two equations in there, you just hit enter, enter, okay? If you had something in y1, y2, y3, and y4, then you would have to pick which ones you were trying to find the intersection of. Do you see what I'm saying? As long as you only have two in, you just hit enter, enter. The third thing it says, though, is guess. Now, this is important for the first time because if you want to find the one on the left, you need to be closer to the one on the left. If you want to find the one on the right, you need to be closer to the one on the right, okay? Or you can type in a guess. Like if I think there's one close to 2, it'll find the one closer to 2. So one of them is 2.7, yes? Then you go all over again. Second, if you got the other one, that's fine. Doesn't matter which one you did first. Second trace, intersection, enter, yep, the parabola, yep, the line. But I want to find the other one, so this time I either have to scroll over or just type a guess over here at like 5 or something. But I have to be closer to this one, otherwise it'll find the other one twice. At 5.5. Okay? Any questions on that? Better? Okay. Can you quickly flip to worksheet 8, side A? All right, this is an example that you could all probably solve quickly algebraically. You could move everything to one side. You could factor, do quadratic, isolate the x squared, whatever you wanted to do. Okay, can't isolate the x squared because it has an x term, but we're going to talk about solving, if you don't have to have an exact answer, how to solve this graphically. Because eventually we're going to have some nasty quasi equations. I'm going to have quasi equations like this.
Yeah, that's my favorite.
Okay? So I don't want to solve that nastiness. Okay? So what we're going to do is we're going to type this side in y1 and this side in y2 and see where they're equal by finding their intersection. That's called the intersect method. Okay? So let's do that really quick with this problem. Type y1 as x minus 2 and y2 as negative 1/2 x squared plus 2. And then work on finding an appropriate window, which you won't have to work very hard, I don't think. For the negative 1/2, it'd probably be fastest to type negative 0.5. I'm going to put it in parentheses and actually type negative 1 divided by 2, close the parenthesis, and then x squared plus 2. I do that all the time. All right. Actually, what was your first thought for the window? My first thought is always to try a standard window. So I did a zoom 6, and it worked pretty darn well. Do you see both intersection points? Okay. It's important you get good at thinking about what you're graphing. Okay, put your calculator down for a second. What is x minus 2? Y equals x minus 2. It's a line, right? And y equals negative 1/2 x squared plus 2 is parabola that opens down. Okay. Is it always going to have two intersection points? No. Could it have one? Yeah, a line could just bump up against, probably easily thought of as at the vertex, right? If it just landed on the vertex. Could it have no intersection points? Right? If we had a line above this parabola, okay? So think about those things, but also think about if it went, if you saw just this part right here, would you think, that wasn't what I meant to do. If you saw this part here, this was your whole window, would you think maybe you needed to make a bigger window because it might continue out here? Do you know what I'm saying? You got to watch that there's sometimes hidden intersection points. All right, anyway, that being said, this one would have at most two. Let's find them quickly. Second trace, intersection. I just hit enter, 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 and found. One of them is at, anybody? Or I confused my calculator because I hit enter too fast. Okay. This is why everybody gets this problem wrong on a quiz. This should be the easiest question ever, but people write this down. Okay? Let's find the other one, and then I'm going to talk about why it's wrong. I'm going to say the other one's somewhere over on the negative side. -4, -6, is that right, guys? Okay, really quick sketch, which mine will be bad, I promise. Okay. Why, if this was the original question, why is it wrong to write 2, 0 and -4, -6? Is there a y anywhere in this equation? No. The answers are 2 and -4. Where does that 0 come from? If I put a 2 on the left side, guess what I get? 0. If I put a 2 in on the right side, I get 0. Okay? If I put -4 in on the left, I get -6. But the only values that I can put in that will make these equal are 2 and -4. So just be careful you don't write down ordered pairs when it asks you to do that. All right. I'm going to skip this question because it's super easy, but let's try it visually without typing it in. If you already typed it in, go for you. Good job. What is this one? Parabola slid down 4. This one is a parabola slid up 4, but then opens down. Guess what? They intersect at. Did anybody already type it in? -2 and +2. All right. So I think you guys could all have done that, yes? I'm just trying to not waste your time because I know you're better with the calculators than some former students have been. So I'm trying to go quickly here. There's a second method I want you to get good at. That is getting it all to one side and setting it equal to 0. What are you going to use then to find where it's equal to 0? The 0 feature. Okay. I do want to do this one because I want to talk about an appropriate window. So can you type this in real fast? (7x squared plus 7x minus 15). Plus would be good in there, half hour. Yes. You'll be good. Just be ready for the quiz and the homework check. Okay. not a horrid window. If I only wanted the zeros, are there, the 2 zeros are in this window, yes? Eventually, my requirement for a good window for a polynomial will be include all the x-intercepts and all the points connecting in between. All the points in between. So this has both x-intercepts, but what am I missing? Yeah, if I try to go from one x-intercept, I'm cutting off the bottom. You see what I'm talking about? Okay, so you could just make some more negative x. You could make a y, negative y, my bad. Make the y min negative 20, because we need it to go down a little further. That's not a great window to me. It would be fine. I wouldn't count it wrong. But I would like to stretch it out a little bit more this way, so I'm going to say the x is like negative 5 to 5. Because I really don't care about, I got an extra graph on both sides. And that looks a little more like a parabola to me. Now, you have to know that that's not really what this looks like if we did the same scale on the x and y. It really is a really long, skinny parabola. Okay. All right. We're trying to find the zeros, so you want to give me an estimate? As it wants a left and a right?
I'm gonna 1 for the right.
Okay. If it's at positive 1, what's a little bit to the left and a little bit to the right? 0 is my left bound, 2 is my right bound, enter. Was it exactly 1? No. If you had thought, I think that's at exactly 1. You could have just hit 1, enter, and it would have said, oh, well, guess what? It's not, because at 1, it's actually down at negative 1. Okay? The 0 was at, I don't remember, anybody, 1.04 or something? Okay, 1.04 gobbledygook, 1.047, okay? Now, if I put 1.047 back into that equation, am I going to get exactly 0? No, but pretty darn close, depending how many places you go. If you round to 1, you're not, right? You're going to get it negative 1, because we already tested that. I thought this one was maybe negative 2, so actually I tried typing negative 2. It's not. It's a little bit below, so I went over and did 0 again. Left bound, right bound, what do you think that one's between? Gotta start on the left. Negative 3, and yeah, negative 1 would work. I put 0 because I'm lazy. At negative 2.047. So we wound up using a window, I did anyway, of negative 5 to 5 and negative 20 to 10 maybe? Was it opening down, wasn't it? I already forgot. Looked like that. All right. I would like to run a trial. You ready? I would like half of us to use each method on this question. Okay? One method would be to type this in Y1 and this in Y2. What is the other method, though? Before you do that, I want you to tell me what the other method would be. Yes, move it all, set it equal to 0. So like a negative 83x squared plus 98x plus 9 would be minus 24, I think. You'd put it in y equals, sorry. So pick which method you want. Now, is everybody's going to look the same? There's actually 3 different graphs that could happen. One would be you'd get 2 parabolas if you put in y1 and y2. One would be a parabola opening down, which I'm going to get because I did negative 83x squared. If you moved it to the other side, you'd get a parabola opening up. It'd have the same x-intercept, so it would just be flipped over. Hit on. Did I not talk about that, guys? Anytime your calculator's doing something weird, or it's got that little worm up in the corner going up and down, up and down, up and down, and it's frozen, just hit on. it breaks the program, and then you can go back and hit graph or y equals or 7 or whatever you want to type. They got so mad at me yesterday when I told them that in one class because they said, no teacher has ever told me that before. I've wasted hours of my life looking at the calculator waiting for it to unfreeze. And just hit on and you're good to go. All right. Yeah, I don't. Oh, my window's not miserable. I'm going to go like -1 to 4 and -10 to 10. Okay, did anybody use the intersect method? I like the intersect method better because I'm not real fond of left bound, right bound, honestly. Left bound, I'm going to go 0, right bound, 0.5. Ooh, did I find one? Yep, I got 0.3467. Anybody get that one? The other way will work.
When it says graph y equals, and we did the other way.
That you would have to have 2 y equals. Yeah, the directions said for this section to use the 0 method. Yeah, I just didn't follow the directions.
What is that? It's having a major dot on the one, but it's not supposed to.
Okay, the other one I found is 0.834. Yes.
Yes.
Okay. Let me show you this. A student taught me this, and this is my favorite method of finding zeros. You can use intersection to find zeros. If you put in y2, what?
0.
If you go to y2 and you type a 0, now to find the zeros, you can use the intersection method. Enter, enter, enter. It finds this one. Well, I gotta go enter. Oops, whoops, whoops. I didn't pick 0. Enter, enter. I'm going to pick the one. My guess has got to be something. Really?
Well, that happened to me earlier.
I picked 0, dingbat. Trying to do it by intersect. Why didn't anybody tell me I'm picking the wrong thing? Okay, enter, enter, and then pick one closer to 0, and that'll find the other one, okay? So you can use intersection as long as you put 0 in one of your y equals. All right, let's do this one, and then I'm going to call it a day. We're not going to do the back until next week. The fun word problems we'll save for next week. Can you graph this and find an appropriate window for the word problem, please? And honestly, this question would be much faster solved by hand, but we're going to do it this way. I care because it's a word problem. What is an appropriate window for this application? Okay, time. How long do you think, if you drop something off a building, how long does it take to hit the ground? 82 seconds? I can't even think how high you'd have to be for it to take 82 seconds to hit the ground. I'm voting if you drop it off a 100-foot building, it's not going to take that many seconds. I'll go 5, 6, 7. Yeah. And if it was a 96-foot building, the top should be at what? Like 100. So this is looking like a pretty nice window to me, yes? Do you understand why this is a nice window and not seeing the whole parabola? Because I can't have negative time and I can't go underground. I only care about the first quadrant part of it, right? All right, what time does it hit the ground? We could use what? We could use the 0. And it's somewhere between, my left is going to be 2 and 3. You can scroll around. I got 2.449, 2.45 maybe. Yeah, very close to 86. I think we should do that problem. Okay, so why did I say that would have been much easier, more quickly done? Yeah, if you put it equal to 0, you'd have subtracted the 96, divided by 16, and square rooted, right?
Yep.
Okay. What did we, I used like negative 10 to 100 and wound up with a picture like this. Okay. So, is anybody going to actually work on worksheet 8 tonight?
The possibilities are endless.
Okay. If you were, it's actually 9, right? The assignment that goes, okay. The assignment that goes with this is worksheet 9. If you wanted to do side A, which doesn't have word problems on it, let me just show you something. What I want you to do is to solve graphically, it says, okay? And it says show what you entered in your equation and sketch, use both methods. So maybe for the odd ones, use the intersect method, and for the even ones, use the get it equal to 0 method, okay? You get what I'm talking about? Or pick the ones that's already equal to, this one's already equal to 0. That would be really good. The one that's already equal to 0, use that method.
I feel like approximately 3 that were already equal to 0.
Good choice.
Because then I don't have to worry about.
And do a sketch, please. It does say, I think, somewhere, show a sketch.